Assalamualaikum warahmatullahi wabarakatuh. My name is Luqman Adili and my teammate is Anis Noain and Muhammad Firdaus. Today we're gonna present about Lab 1 PLC, perform principle of programming PLC. Okay. Next. Okay, for the introduction, a PLC or programmable logic controller is a compact computer used in industrial setting to centralize control of various system process. PLCs serve as the brains of industrial automation equipment, capable of executing multiple tasks simultaneously through built I/O modules for inputs and outputs. PLC are also widely used in diverse sectors due to their reliability, flexibility, cost effectiveness, speed, connectivity, and data processing capabilities. Their key feature is the ability to reprogram PLC, making them highly adaptable to changing process or application requirement. AnyDesk also is used. AnyDesk is remote desktop software that enable remote access to computer from anywhere in the world, supporting cross-platform connectivity and offering features such as remote access, file transmission, and VPN capabilities, making it a secure and dependable option for IT workers. TIA Portals is the automation platform developed by Siemens Industry, designed to automate various equipment and units in and around a factory, such as pick and place robot, filling machine, welding robots, and compressor and drive. This is the software and hardware we use. We have three: Siemens S7 1200, Symmetric Comfort Panel TP700, and TIA Portal V15. This is our input and output device. You can see here, input device, address, output device, and address number.
Okay, next I'm going to present about the flow chart. Okay, so at the beginning is start. So if there will be a reset and set. So if we press yes, then it will go to T system on. And if we press no, it will be also go to the T system on, but they are different in auto mode and manual mode. Okay, if T system on, if we press yes in the auto mode, there will be go to the push button and let indicator on, conveyor move to the right, sensor B1 and B2. And then if we place the new part on the conveyor, it will be a constant light. And if the sensor detect, it will be flashing light of 1 Hertz. And if the conveyor is moving, there will be a flashing light 2 Hertz is 2 Hertz, and then it will reach the light barrier and then it will end. But if we are on the manual mode, there will be two conveyor to the right and also conveyor move to the left, and then there will be horn of 2 Hertz. Okay, next, Muhammad Firdaus.
Okay, the Q&A is, I agree. The wiring diagram is exercise 1. Okay, can you see the Siemens for the diagram wiring? Can you see the N1 is connect to about the live and neutral, neutral and neutral. Adding of the adding. Okay, can you see the 001 as LED to loop in about the M and M1 to loop in other that. Okay, next the 2M 2M the red looping about the red right, and to put the output in 0.1. Okay, next. Okay, the wiring diagram for the accessory. The first you can see the M to connect about the push button rate, and output the go to the 001. Okay, the input about the push button green. Can you see the 0.6 to to look about the 1M. Yeah, okay. Okay, next. Okay, the analysis discussion. Can you see the default value of the input and output the conveyor system using the default stack? This make easily to make a ladder diagram because the input and output are already set. In the exercise, there are two movements for the conveyor, the right and to the left. If the right input, the 0.2% is preferred in the conveyor will turn to the right percent about the 0.5. The conveyor will the turn of the to the left 0.6 if the 10.3% input the press. The input the 0.2% and 0.3% are a simulation prefer the conveyor will not move or the rotate in the direction locked out. The three are the programming and operating mode selection and interlocking in the manual mode 0.1 as an additional condition for running the conveyor motor. The goal of the exercise is to add to automatic and manual mode to the conveyor. The system on the 0.0 Q will be turned on using the momentary contact the simulator 0.0 I if input the 0.4% in the turn off. The manual mode has been selected by the default. If the input 10.4% in the turn on, the auto mode will be selected by default also when the manual mode is turned on. The job conveyor motor then already program can be used to integrate the manual modes. Okay, next.
Okay, next for the analysis and discussion for exercise 4. The conveyor is set to auto mode and the component are moved from either bay 1 or bay 2 to the final check, which should be presented by a light barrier. So the conveyor operates on the right side when bay 1 is pressed and not bay 2. When the part reach the final check position, the run conveyor right is stopped and the conveyor stop when it reach the LB and the auto mode switch off. In exercise 5, previously in manual mode, the conveyor direction could be controlled using momentary contact input 0.2 and input 0.3 to jog the conveyor to the right or left. But in the auto mode, the conveyor would run to the right when a part was placed in front of the proximity sensor in bay 1 or bay 2 and the corresponding momentary contact was pressed. The conveyor would stop when the part reached the final check or when auto mode was turned off. Now the system needs to remain unchanged. The conveyor motor needs to stop as soon as the part passes through the light barrier in the auto mode. In exercise 6, when the auto mode is on output 0.2, the indicator light will show different signal depending on the state of the conveyor. A constant light indicates the new part can be placed on the conveyor. 1 Hz flashing light indicates the proximity sensor has detected a part of a specific bay, but the conveyor will not start moving. 2 Hz flashing light indicates that the conveyor motor is moving, and in manual mode, the horn will sound a 2 Hz pulse tone in the conveyor motor that is jogged to the right or to the left. Next, I pass to Luqman.
Okay, for the last conclusion and recommendation, by completing this lab, all the tasks has been complete and the participant were able to create a PLC program using Siemens S7-1200 and learn about PLC programming, ladder logic, and other ladder logic instruction. A structure approach was used including sequence description, timing diagram, wiring diagrams, and ladder logic diagrams to create a programming routine for specific case studies. And for the recommendation, We suggest to learn the schematic S7-100 with HMI interface, as it can be beneficial for future system. The schematic S7-100 controller offer high performance and built-in versatility for future needs. Its modular structure allow for easy integration into sophisticated machine design, providing reliable support during the digital transformation, while the S7-1200 generation is interchangeable in many situations. It incorporates the latest and the future-proof technologies for an automation system with enhanced feature. With TIA Portal Engineering System, which serves as a common platform for all schematic controller, the S7-1200 is designed to adapt to fast market change, shorter product life cycles, and increasing cost pressure. Okay, that's all. Thank you, Roslan.
That's all for us. Thank you. Okay, Assalamualaikum and good afternoon. So today we are going to present about the demonstration of Lab 1. So my name is Anis Rain and my teammates are Muhammad Fidaus and Lukman. So back to the system operation. First, as for exercise 2, we need to turn on the system operation. So as you can see here, I already turned on the T system 1 to force 1 and T system off to 1 also. So the L system will be turned on. As you can see, the green color current flow. So here's my force table. Okay. Okay, next I'm going to share about exercise 3, which is the mode selection. Okay, then we have to run. Okay, so here we already open the current flow for auto mode. So L system must be forced to 1, and then the mode select also must be turned to 1, and also TMA mode accept must be turned to 1 to make the LO2 current flow. So here's the force table. Okay, so how to next I'm going to explain about the manual mode. Okay, if you want to turn off the turn on the manual mode, we must change the L system to on. Okay, and then T system off must be forced to 1. Okay, MS set must be 1. Okay. I don't know why we have duplication here. Okay, system 1. Element set must select speed off. Okay. So now here's the truth table that I already set up. So now as you can see, the L system is already turned 1 and SM mode select also 1 and then accept also 1 and we got the manual mode. Okay, so here's the truth table. Okay. Okay, next I'm going to explain about the jog to the right and jog to the left. System operation. No. No. Mode selection. No, manual mode. Okay. So this is the diagram for jog conveyor to the right and jog conveyor to the left. So now we turn open for the current flow. Okay. So now the manual right is currently off for the jog conveyor to the right. So we must turn on jog to the left. Okay. So T system is on. T system off is also on. Okay. And then T jog right must be 1. Pause to 1. T jog left must be false. Okay. T jog left. T jog left must be false to 0. Okay, and then mode select must be 0. Okay, 0. Okay, so here's the job conveyor to the right. Okay, see the truth table. Okay, next is job conveyor to the left. And the network tree is actually the replacement. Okay, so now it's job to the left. Okay, the system must be on, 1. The system off also, 1. T job left, T job left. T job left must be 1. Okay. Oh, here's a duplicate. T job left must be 1. And then turn off the T job right to 0. Okay. Mode select, mode select, mode select. Mode select also false. And TS set must be 1. TS set. Okay, true. So here's the job conveyor to the left. So there's a current flow. So here's the force table of the job to the left. Okay, next I'm going to pass to Lukman.
Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm gonna explain about exercise 4, auto mode, and exercise 5, instruction. First of all, there's a connection between these two questions. Both questions are related to operation of conveyor system and auto mode, which specific condition for starting and stopping the conveyor motor. In exercise 4, the conveyor motor is start in auto mode based on the occupancy of proximity sensor in bay 1 or bay 2, as well as the status of momentary contact in bay 1 or bay 2. The conveyor motor is stopped when the part reach the final check, or we call it light barrier, or when auto mode is switched off. And in exercise 5, the requirement is to stop the conveyor motor as soon as the part has passed through the light barrier. This indicates a change in stopping condition of the conveyor motor in auto mode. Previously, the conveyor motor was stopped when the part reached the final check or light barrier, but now it's need to be stopped as soon as the part has passed through the light barrier. Okay, for exercise 4, the auto mode, imagine you have a conveyor belt that moves things from one place to another, and you have a special mode called auto mode. When the conveyor belts move things automatically without anyone controlling it. In auto mode, we want to transport part of either bay 1 or bay 2 to a place called final check, which is like a special area with a light barrier. Here's our results for exercise 4. The conveyor belt will start moving to the right when the proximity sensor in sense that something is there, like a part and like part N. The proximity sensor in bay 2 sense that nothing is there, is not occupied, N. Someone press a button called bay 1 momentary contact, or the other Other style that can move to the right is the conveyor belt move to the right when quantity sensor in bay 2 sense that something is there, like a part N, or the quantity sensor bay 1 sense that nothing is there, or someone press a button called bay 2 momentary contact. The conveyor belt will keep moving to the right, this until the part reach the final check, which is like the finish line, or until someone switch off the auto mode. So in simple words, when there's a part in bay 1 and bay 2 is empty, and someone press the bay 1 button, or when there's part in bay 2 and bay 1 is empty and someone press the bay 2 button, the conveyor belt will start moving part to the final check automatically. It will stop the parts reach the final check or when someone turn off the auto mode. And for exercise 5, the edge detection. Okay, so imagine you have a conveyor belt that moves things from one place to another, and you have a special mode called auto mode when this conveyor belt moves things automatically without anyone controlling. Until now, in auto mode, the conveyor belt will start moving to the right when part is placed exactly in front of bay 1. In bay 1 or bay 2. And the button for that bay is pressed. The conveyor belt will keep moving to the right until part reach the final check or someone turn off the auto mode. But now we want to make a change. We want the conveyor belt to stop as soon as the part pass through the light barrier, which is like a special gate that the part goes through. So as soon as the part goes past in the light barrier, the conveyor belt should stop, and even if auto mode is still on, everything else in the system will stay the same. We will use the proximity sensor in bay 1 and bay 2 to start the conveyor belt, and we will still use the momentary contact for the occupied bay to control the movement. The only change is that the conveyor motor will stop as soon as the part passes through the light barrier, even if the auto mode is still on. This is the result for compilation result of exercise 4 auto mode and exercise 5 edge detection. For the conclusion is both questions involved in the operation in the conveyor motor in auto mode and the condition for starting and stopping the motor, with exercise 5 specifically focusing on modifying the stopping condition to stop the motor as soon as the part pass through the light barrier. Okay, that's all from me for exercise 4 and exercise 5. So I will pass it to Firdaus.
Okay, Assalamualaikum. My name is Firdaus. Okay, today I present about the indicator. Okay, indicator. Can you see the network one? The first floor is bay 1 and bay 2 to convey it right, and the L auto, L B, the clock and 1 hertz, and a bay 1, a bay 2, and conveyor right. Can you see the flow at the graph, and a clock 2 hertz to a conveyor right. Okay, the force table. Can you see the force table? The system is on, true, and about the bay 1 is on. The L the L1 is true, and the bay 2 is false. Bay 1, can you know the accept about the graph the inductor can give the auto and L bay 1. The conveyor can stop the stir after the right, and L auto can run until this switch. Okay, can you see the LB force? LB1 and it's a conveyor. Okay, the conveyor the conveyor right. Can you see the right? Mana right? Conveyor right. Can you see force 1? Okay, the flow can non-auto because the clock has a block at the B2. If B2 block, can you see the B1 can move the L auto, can go to the L auto. Okay, the indicator 2, B2. The B1 and B2 has a flow about the conveyor right, can auto and LB2. And the clock 1 Hz can stop and about B1 to B2 and a conveyor cut off the conveyor right ni. This clock has 2 Hz and conveyor right has a flow at about the L auto and LB2. Okay, the network tree, can you see the L-man? The L-man can you see the L-man is a flow about the jog right and the clock 2 Hz and 2 horn and a stop because not stop because that is blink about the horn. If the jog left off, check. T jog left off, can you see the force? Can you see the blink has a stop because the jog left and cut off above the clock and horn. For I push that force 1. Okay, true. Okay, can you see the blink as a horn? Okay, okay, that's all. The next horn sound. Okay, the horn sound. The horn about the conveyor left, the clock and 2 Hz and L-man. Okay, you see L-man the flow horn. Can you blink at the right of the jog right? Jog right. Okay. Wait, the I want off about the conveyor right. Because I want off the flow. Okay, jog right. The same after. Okay, jog right. Oh, the same. Okay, the horn has be moved about the horn and element and conveyor. Conveyor right can move the clock and element gets a blink for the sound. Can you see the sound can stop if we close the circuit, and that horn can and can give the horn. Wait. Accept about the true. Okay, about the true. Okay. Okay, that's all for me. Thank you. Janice.
Okay, next,
Ya, aku tak.
I think for the indicator, then we play for Firdaus part. Oh, the LO2 is off. So we must check the system. Too many. This one. Okay, we must open this one. Force table. Okay. Auto. So the system must be on, as I mentioned earlier. And then the system off must be true also. Okay. And mode select must be on. Okay, so now auto mode is on. And then indicator. Wait. So here's the indicator. Indicator B2 has been operated. As you can see here. And this is the force table. I zoom it for you. Okay. The current is flow. And this is the force table. Okay. Then also for the indicator 1. Also the current is flowing. Okay, so that's all. Next I'm going to pass to Luman for conclusion and recommendation.
Okay, for the conclusion, okay. Okay, for the conclusion is conclusion. A programmable logic controller (PLC) is a specialized computer that is used for controlling and operating manufacturing process and machinery. It utilizes programmable memory to store instructions and carry out functions such as on, off, control, timing, counting, sequencing, arithmetic, and data handling, and whatsoever. So, in this lab, we use Semantic S7 solder and Semantic base, and it can be beneficial for future system. This system also controls offer high performance and built-in versatility for future needs, and its modular structure allows for easy integration into sophisticated machine design, providing reliable support during the digital transformation. Okay, I think that's all from us. Thank you.